With the next example, once again with the same principle of homogeneity, based on that there are many examples and they are beautiful, and standard of the question is also wonderful, my dear. Now look at this example. By the question is given by the method of dimension. See, by the method of dimension, that is by the method of principle of homogeneity. So by the method of dimension or by the principle of homogeneity, that any time if the equation is given like this, or any equation which I have given in first two example, if the equation are like that, see to it that you are using principle of homogeneity. Unless and until there are some other rules of the dimensions which you have stated by the question paper. The question paper will tell you that this method you are supposed to use. Or sometime you yourself and think about it, that which method I supposed to do so that my question will fulfill the things. That by method of dimension question is check the accuracy of a given equation. So in the exam also, if we can give the question like this, we have given this question suppose, and we say by the method of dimension check the accuracy, and that accuracy doesn't mean error accuracy. Accuracy here means correctness. Check the correctness of the given equation. So now my dear, this is one thing, that how the question will be interpreted in the exam, that also should aware about, because there are three uses of dimension. So in the exam, which use we are talking about, we will say dimensionally method to use karo, check karo the accuracy. Immediately you should understand, sir, I have to use the principle of homogeneity. Now here my dear, let me tell you, in the given equation, delta is delta. This is called delta. Or I read this delta. So you should know reading of this term also. This is delta, and this gives depression. Depression of beam. You know beam. We are using beam while making houses. We are using beam while making bridges. Bridge banate samay, house banate samay, we use a beam. Right? We call it beam bar. Beam, right? And that beam, my dear, that beam depressed. If there is a load over the load, load पे load रखेंगे तो कोई भी beam depressed होता है, depressed. So here delta is a depression of beam, and depression will be done in terms of meter, centimeter. Depression in beam will be occurred in what? In terms of meter or centimeter. Sir, इतने centimeter से beam depressed हो गया. So my dear, here depression is nothing but, मैं थोड़ा सा knowledge देता हूँ, is nothing but length. Here the depression is nothing but length. Take care. So that you should know what should be the dimension for delta. It is the dimension of length. Because I said depression of beam. And I have given you example also, please. And depression is done in meter or centimeter. And meter is a unit for length. Centimeter is a unit for length. So depression has a dimension same as the length. Now next is m. You know m is mass. G is acceleration due to gravity. Here I will give small concept. Mg together called weight, load. Here mg together called, I can see my dear, you are a small kids, you can find out their dimensions separately. M dimension separately, G dimension separately. But if you are a good student, my dear, here mg is a weight, and weight is nothing but force. So dimension of mg together will give the dimension of force. हम लोग चेक करेंगे, m के डायमेंशन को सब्स्टिट्यूट करेंगे, g के डायमेंशन को सब्स्टिट्यूट करेंगे, मल्टीप्लाई करके चेकआउट करना, you will get the dimension of force. So I have given little knowledge here that mg in the equation, this together mg can be called as weight. But since you are a small boy, small girl, बच्चे, small kids, so now I will request substitute individual dimension. But if you are quite matured and if you directly know mg is a weight, called gravitational force. mg is a gravitational force. Sir, gravitational keep one side, it is ultimately force. So dimension of force is applied to mg. Or if you don't recollect this, substitute dimension of m, substitute dimension of g individually. No issues. Now next is L. L is length. B is breadth. B is breadth. D is depth. And Y is Young's modulus. Of elasticity. So this is all is a given, you can say, physical quantity in the equation. These are the given physical quantity in the equation. My dear, I think I know all the dimension. I know all the dimension. We know length ka dimension, we know mass ka dimension, we know acceleration due to gravity dimension, that is acceleration dimension. We know length dimension, we know breadth, we know depth. Only the problem is we don't remember Young's modulus of elasticity dimension. That we will do in rough and we will substitute here. We will do in rough and we will substitute here. So I hope you understood this much in the video. This is all clear to you that these are the physical quantities stated. Now let's go for the dimension of this quantity. Now LHS, left hand side, this I will put it as equation number 1. LHS, that is left hand side, it is depression delta. So dimension of delta will be nothing but, sir, L1, M0, T0, because I have explained everything that delta, this is called delta. Delta means depression of beam, and if any beam, we are using making bridges, I said, we are using the beam making houses. So any beam get depressed, sir, it will depress in terms of meter or centimeter. Actually in centimeter, meter बहुत बड़ी बात हो गई. So it will depressed in terms of centimeter, but centimeter is a unit of length. So this is the way we identify that delta is length. So dimension of delta is become L1, M0, T0 according to the statement word depression. Now my dear, I will put this as equation number 2. On the right hand side, there is a big term, and that is mglq upon 4bdqy. This is the term on the right hand side. So here I will substitute, and here I will substitute dimension of m, that is m power 1, dimension of g, that is acceleration due to gravity. I told you long back, acceleration due to gravity has the same dimension as acceleration. So it is L power 1 t power minus 2. That is the dimension of acceleration. Here dimension of L cube, that is L is length. So it is L cube as it is, whole divided by 4 is not included because here I will write, since 4 is a number, hence it is dimensionless. This reason I will write. Though it is written in the equation, but here I will not mention any 4 anything like that because I have given the reason. Now so dimension for B, that is breadth, is again L1. Dimension of D cube, D is depth, again it is length because I told you breadth, depth, length, height, radius, everything is length. So here it is L and D cube, so here it is L power 3, and now the dimension of Young's modulus. So here I will do the rough work. Young's modulus dimension is the dimension of stress upon dimension of strain. Because I have not remember what is the dimension of Young's modulus, so I am doing on one side. So this is all is the method, my dear. So here strain don't have dimension, I have already done. This is L0, M0, T0. Dimension of strain, there is no dimension for strain. I have done, look at my videos. And stress has the dimension of pressure. That is force upon area, if you can put. So here I will directly write the answer L minus 1, M1, T minus 2. So the dimension for Young's modulus is the same as the dimension of stress. And dimension of stress is nothing but force upon area. That is L minus 1, M1, T minus 2. Because strain don't have dimension, this is the third time I am revising. Look my videos carefully. For elasticity, constant dimensions are given. So now here I will substitute L minus 1, M1, T minus 2. That is the dimension of Young's modulus. This is the dimension of depth. This is the dimension for breadth. Here dq given, so here lq become. So now what will be the total dimension here? In the numerator it will be, first we will solve numerator. This is M1 as it is, L1 and L3 become L4, M1, T minus 2. In denominator it is 1, 3, 3 and 1, or you can say this is L1 and this is L minus 1. Become L0 and this L3 is as it is, so it is L3. Here it is M1 and here it is T minus 2. M1 T minus 2. Or you can say L3 and L1, L4. L4 में से L minus 1 हुआ, L3 बच गया. This will be your dimension of MGLQ divided by 4BDQY, where Y is Young's modulus. I have substituted here in rough form. Now what is the dimension after overall when I calculate? This is L power 4, this is L power 3. Answer will be L power 1, 4 minus 3. M power 1 divided by M power 1, answer will be M power 0. T power minus 2 divided by T power minus 2 go up, become T power plus 2, minus 2 plus 2 becomes 0. And this I will put it as equation number 3. So now my dear, I hope the question is solved. Here I will write substituting equation 2 and 3 in 1. So 1, this is 1 and this is 2 and this is 3. 2 showing the dimension for delta. I will put it in place of delta. So it is L1, M0, T0. That is equation 2 for delta. And equation 3 is for MGLQ divided by 4BDQY. With the reason I have written 4 is a number all in all, and I have calculated the difficult dimension Young's modulus on one side. And rest all I have calculated. So on right hand side also, entire this 4 MGLQ divided by 4 BDQY has a dimension of, come on, same L1 M0 T0. So now I can say left hand side dimension, here I am writing dimension is equal to right hand side dimension. Hence the given equation is accurate. Hence the given equation is accurate dimensionally. The given equation is accurate dimensionally. I hope my dear you all understood this topic. Now I will go for application of principle of homogeneity. Matlab we know now that every term of LHS and every term of RHS, listen to me carefully. Now we are going for some more tough question, and definitely we will keep asking such questions in the exam. Now we will go for application of principle of homogeneity. Application matlab we have to apply this. Here I am not applying. Here I am proving the equations. Applying is some difficult steps. So shall I go for the numericals based on application? Matlab, and what is the application of principle of homogeneity? Sir, you have to apply this thought. What is that thought? That every term of the LHS and every term of the RHS, term, has the same dimension. This concept now we have to apply to do the numericals which I am giving you now after this. Okay, so please copy it down and then I will show you applications of principle of homogeneity problems on that. So now my dear, as I said, applying the principle of homogeneity. Now here you can see I am using this principle. Now till now I am using this principle, I am equating, I am checking the accuracy and correctness of a equation. Now my dear, applying this equation, I have to do something else. And what is that? Look at this question. The question is f is equal to a root x, where I will tell you, because this is given in the question also, where f is a force, here it is bt square, where f is a force, x is displacement or distance, you can say, no issue, because for dimension displacement distance is length only, and t is time. F is force, x is displacement, t is time, and a and b, you can see, are constants. But my dear, they are constant, but they are not number. So I told you, if they are constant, that doesn't mean that they are dimensionless. And that is the question, what is the dimension of a by b? If the question is what is the dimension of a upon b, it means a also possesses dimension and b also possesses dimension. Okay, it means here a and b are not numbers, sir. If they would have been number, they don't have dimension, but they are constant. They are constant. But this is also correct, my dear. I told you in my all videos that it doesn't mean that all constants are dimensionless. So here in this question, a and b possess dimensions. Okay. So now let's go to this topic. So question is, I hope, very clear. And question is that calculate the dimension of a by b through this equation. And here he said using the principle of homogeneity. My dear, for the exam point of view, say in the paper we are not saying this using homogeneity. But now my dear, by looking the equations, by looking the term, you can see there is a one term, two term on the RHS and only one term on the LHS. So by looking the equation also, or looking the way of writing the question, my dear, you should understand your side only that we have to use the principle of homogeneity for such questions. Now my dear, as here I will write one statement. According to the principle of homogeneity, here is the answer. According to the, because I should write this line, it is important. According to the principle of homogeneity, principle of homogeneity, each term of LHS has same dimension. Each term of LHS has same dimension as that of RHS. According to principle of homogeneity, each term of LHS has same dimension as that of RHS terms. Am I clear? Now, what is the meaning of this line? That is dimension of force will be equal to dimension of a root x. Also, dimension of force is equal to dimension of bt square. This is the meaning. Each term of LHS. Each term of LHS, no doubt that LHS there is only one term, no issue. But each term of LHS, what happens if there are two terms on LHS? So this language is important. Each term of LHS has same dimension as that of RHS terms. Or you can say according to principle of homogeneity, dimension of LHS has same as dimension of LHS has same as the dimension of each term of RHS. Okay, no issue. अब तो clear कि sir LHS में there is one term, so I have written directly that according to principle of homogeneity, what is the principle of homogeneity? Dimension of LHS has same as the dimension of each term of RHS. So dimension of LHS here in the question is dimension of F, and it is equal to the dimension of each term of RHS. So first term of RHS is A root X, so dimension of F is equal to A root X, and dimension of F is equal to BT square also. So now from here, my dear, what is the value of A? So A is, that is dimension of A become, simple algebra, is nothing but dimension of F divided by dimension of root X. This can be written as dimension of F divided by dimension of X power half, because root X should be written this way. So now let's go to this dimension of A is equal to dimension of F, that is nothing but L1 M0 L1 M1 T minus 2 divided by X. X is a displacement, here I have written in the question. So dimension of displacement is L power 1 and this is power half. So now this will become L1 M1 T minus 2 and in denominator it will be L power half. So now what is the dimension of A? Dimension of A will become L power, this is 1 and this is half, this is 1 minus half, because this half go up, here it is M1 and here it is T minus 2, because there is no mass, no time in denominator. So dimension of A will become 1 minus half is half, 1 minus half is half, so it is L power half M1 T minus 2. This I have calculated the dimension of A, my dear. I hope it is clear. Now the next one. Here it is F is equal to BT square. So now here dimension of B is equal to dimension of F upon dimension of T square. This will be F dimension is L1 M1 T minus 2 divided by dimension of T square is T power 2. So now dimension of B will become L power 1 M power 1 minus 2 and this is power 2 will become 0. Sorry. Minus 2 and this 2 will go up, become minus 2. Minus 2 minus 2 will become minus 4. This I got dimension of, this I got as the dimension of B, and this I will put in one like this. Whenever I get the total answer, I put like the box. But the question is, what is the dimension of A by B? Therefore, dimension of A by B is equal to dimension of A divided by dimension of B. Dimension of A, my dear, I got it over here, L power half, M power 1 and T power minus 2. Whereas dimension of B, I got it as L power 1, M power 1, T power minus 4. So therefore dimension of A by B is equal to, let us calculate, here at L power, this is half and this is 1. So now this is half minus 1. Half and this one will go up, become half minus 1. Here it will be M power 1 and M power 1 become M power 0, 1 minus 1. And here it will be T power minus 2 plus 4. this is minus 2 and minus 4 will go up, become plus 4. So dimension of A by B is equal to, now the final answer, half minus 1, 1 is bigger number, so it is L power minus half, this is M power 0, and here it is minus 2 plus 4 will become 2. So this is your final answer. I have calculated the dimension of A by B by applying, you can see according to the principle of homogeneity, dimension of LHS, matlab dimension of left hand side has same as the dimension of each term of right hand side. Matlab F will equate with A root X also and F will equate with BT square also. When it will equate with A root X, it will give us the value for A, and when it will be equate with BT square, the other term of RHS, it will give the value for B. And then with the help of dimension of A and dimension of B, we will calculate dimension of A by B. I hope it is clear. Please write it down, and then I will take one or two more numericals to understand, to make you understand completely about this part, which is based on principle of homogeneity.